Welcome, and thank you for joining us for this webinar presentation. We are the Defense Systems Information Analysis Center, or DSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. DSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the defense systems community. As such, our organization supports those working in the defense systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the defense systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD defense systems research.
Hello, everyone. Welcome. Thank you so much for joining. My name is Taylor Knight. I am a research analyst with DSIAC, and I'm hosting today. We are very excited for Dave Hall to give our presentation, this webinar. And before we get started, I just have a few pointers to go over. If you're in the online browser, at the top middle of the screen, you'll see a chat kind of bubble icon. If you hover over that or click that, that's where you can type any audience questions that you may have during the presentation. And we'll do a Q&A session at the end, and we'll go through all those questions at the end instead of throughout the presentation. And to not confuse that with the attendee chat that's over on the left-hand side, that's more so if you're having any issues and you need to interact with one of the DSIAC team members, that something's going on with your technology or something of that nature. Also, if you notice that you're having any technical difficulties, I would suggest dialing in using the number that we'll post in the attendee chat. You can also download the slides from there as well. Follow along as you're listening. And if that doesn't work, then this is recorded, so you can always catch up later. And as always, I would encourage you to visit DSIAC's website, learn more about us, what we do. It's kind of where we also promote our other webinars that are upcoming and house our recorded ones that we've done in the past. So at this time, I'm going to hand the mic over to Dave Hall, and we'll get started.
Okay, good morning. I seem to have lost the ability to change the slides, but I'll just get started. This is a description of a process that's used at the Naval Air Systems Command for doing accreditation support to models and simulations for not only models within the Navy, but we also support the other services as well. If you imagine yourself as a model and simulation IPT lead supporting a DoD acquisition program, and your program manager has told you that you are responsible for him being able to justify using all the models and simulations that are being used to support requirements development, spec compliance, developmental and operational test evaluation. And this is your budget, and oh, by the way, you're probably going to get cut by 10% sometime in the next couple of years. On the other hand, you've got independent V&V contractors that are telling you it's going to cost 3 times your budget to do what you need to do, and they don't see any way around that. So what do you do about that? So what this process that I'm going to describe is sort of what you do about that in terms of making VV&A and establishing the credibility of a model in a cost-effective manner. And Taylor, I don't seem to be able to change the slides.
We'll get you there. For now, if you can just say next slide, and then we'll try to fix that for you.
Next slide. So this is kind of an overview of what I'm going to talk about. The basic key here is that we use risk as a metric for how much V&V and credibility information you need to make an accreditation decision. What's the likelihood that the model is going to be an error? And if it is an error, what's the consequence of that? And we do that analysis as part of the upfront setup for the whole process, because that identifies what needs to be done to mitigate any risks that you've identified, and establishes basically a V&V plan and an accreditation plan that you can follow then throughout the rest of the program. So if you go to the next slide. Next slide. Yeah. So what is V&V to start with? These are the official DoD definitions you've probably all seen. Essentially, verification is, did you build the software right to match what you thought you were trying to do? Did you build the model right? Validation is a look at, did you build the right model? That is, does it really match the real world in the way you intended for the purposes of your use of the tool? And then accreditation is a decision that, yeah, it's close enough and I can use it based on the information you've given me. So V&V are really processes, and accreditation is a yes or no decision based on the results of those processes. So next slide. But how does that all relate to credibility? I talked about model and simulation credibility at the beginning, but how does that relate to VV&A? How do you measure credibility? And how do you know when you've got enough credibility to justify using the tool? And so what I'm going to talk about is how to answer these questions in the way we do it. So next slide. So I gave you a hint at the beginning. How much credibility is enough depends on risk. If you're trying to get from your problem on the one side to a credible solution on the other, and you're using in models and simulations, if there's not much risk involved, if the model is wrong, that is, if the bridge breaks and all you do is get your feet wet, then you don't need a lot of support for that bridge, that tool, to use it, because there's not much risk involved. But if you go to the next slide, if you have enhanced risks involved, next slide. If there are more risks involved, if you fall in and something's going to kill you, then you need to have a lot of evidence supporting the use of that model and simulation to cross that bridge between the problem and the solution. So what I'm going to talk about now is what sort of evidence do you need to build the pillars of that bridge so that you can get across there in a safe and reliable manner. So next slide. So what do you think about, most people think about when you think about a credible tool is it validated? That is, do I know how it compares to the real world? And it's an interesting problem, because how do you define the real world? You can't actually go out and collect everything there is known about how the system you're modeling acts in the real world and do a real detailed, complete comparison of that. You have to have some sort of representation of the real world. And we think of that in three different ways. The first way to do it is to compare your tool with another model that people believe, because the other model is a representation of reality that somebody has accepted and used for other applications. So you can compare it with another model, benchmarking. You can compare it with how subject matter experts in the field believe that the real world operates in the domain that they're interested in. So face validation is really a comparison between how the model behaves and how subject matter experts believe it should behave based on their experience. And the last one is the one that everybody thinks of, when they think of validation is we're comparing the model actual test results. And we call that results validation. And all of these three different ways make up output validation. That is, you're actually comparing the outputs of the model with some representation of the real world. But these all have known problems. I mean, how do you really know whether the benchmark simulation is credible? That it does it really match the real world or not? You get 5 SMEs in a room together, you get 10 different opinions. So, it's hard to kind of corral subject matter experts to think about what your problem is and trying to get them to agree on whether or not your tool matches what they would expect. And of course, the problem with validation testing is it's really expensive. It's hard to do. You can never collect all the information and the parameters you need to really compare with the model. But you can do some combination of those three and approach some sort of validation credibility, I guess you'd say. But there are also other measures that we can look at in addition to validation in terms of model credibility. So if you go to the next slide, now I say I'm talking about these pillars of the bridge. Validation is the one on the right, and I was talking about output accuracy. That is, how well do they compare to the real world? You've also got data accuracy, which is a piece sometimes people forget when they do V&V. The model is not any more than the data that goes in or is embedded in the tool. So you have to do data V&V as well. And then software accuracy is what we think of as verification. Does it meet the specifications that you set when you said what you were going to try and build? So we've got 3 pieces of V&V, but that's really just the middle of the bridge. If you go to the next slide, there are the end pieces. The tool has to somehow tie to your requirements. Now, if you're building your own simulation to do a new system development, say you're modeling a new air vehicle, then presumably you've got requirements all established that you're going to follow, and so that's sort of automatically taken care of. But unfortunately, what happens in DoD a lot of the time is people pick up another simulation that was developed for something else, or it's a tool that's sort of widely used, like a joint aircraft survivability program model of threat systems that everybody uses. And you were not involved in the development of the requirements for that tool. So what you have to do is list what your requirements are for that tool's use, and then compare what you know about that model with how it matches your requirements. So you have to look at, does the model really do what I need it to do in the first place? And on the other end is, okay, I've got a model that does what I need it to do. I've shown that it's accurate enough for me, but how can I be sure I'm not misusing it? That is, usability doesn't just include ease of use. It's what processes are in place to make sure that you know what version you've got, what the features of that version are there user groups to help you get up to speed on the tool, what's the documentation looks like, how is the configuration managed, that sort of thing. So you got to not only tie the model to your problem and see how accurate it is, but you also have to make sure you're not misusing it. So if you go to the next slide, how we define credibility then, function of those 3 things. Does it do what I need it to do? Is it accurate enough for how I need to use it? And can I be sure I'm using it right? So this is really a definition of modeling and simulation credibility. Of course, that function is ill-defined, but it's a combination of those 3 things. So if you go to the next slide, once you've got all that done, then somebody's going to have to make a decision that, okay, I can justify using that tool. And if you don't have enough information, you're sort of hanging out on a limb. But if you have enough information and you've got V&V products and capability and usability information, then you've got something to stand on to justify your decision. And all the DoD service and agency policies require some aspects of capability and usability in addition to the V&B stuff. So this is not just from out of the blue. So essentially, the essence of accreditation then is you're what your requirements are in terms of capability, accuracy, and usability that you've helped the user define, the user here being the acquisition program manager or the M&S IPT lead. And you're comparing those requirements with what information you know about the tool in terms of those things. And usually, or really it's almost always provided by the model developer and the model proponent. And with that comparison, then you can identify what deficiencies there are. Are there workarounds for those deficiencies? Am I going to have to constrain my use of it based on limitations? Or are there things that have to be improved? Or don't I have enough information? If I don't have enough information, I can loop back and collect that information and then make an accreditation decision. So accreditation is an objective comparison between these two things. So V&B is a process, and accreditation is a decision, and risk is the metric. You can't say, is your model validated? You have to say, do I have enough information to know whether it works well enough for me? And well enough for me is how much light do I need to shine on the credibility of this tool to do what I need it to do. If I'm stumbling in the bathroom in the middle of the night, I don't need a lot of light. But if I'm shaving or performing brain surgery, then I need a lot more light. The same is true with how you're using it within the acquisition program lifecycle. If you're early in the program, you don't have a lot of information. You don't have test data, obviously, on your system. So you're going to have to get by with less information than you'll have later on. But once you get to spec compliance, and certainly if you're in an operational test and evaluation, you need a lot of light on the credibility of the tool in order to justify its use. Operational test guys are extremely skeptical of modeling and simulation. So once you get to that point, they're going to lead a lot of convincing. So this is the NAVAIR process. I'm not going to go through every box in this slide while it's up. But the point I wanted to make here is that there are a lot of people involved. The early steps, excuse me, which we'll talk about later, have to involve the program manager or his representative, the model user, and the model developer to really develop the requirements and the acceptability criteria for the tool. We've got subject matter experts involved, a VV&A team, and down at the bottom, the accreditation authority has to get involved because he or she has to understand what the justification is and how all this worked and fit together. So I'm going to kind of step through some of those steps without sticking directly to the boxes. Excuse me. What you start with is an intended use statement. If you can't write down in specific detail how you're going to use this tool, then you can't really decide whether it's good enough for you to use it. So the first step is to develop a specific intended use statement. And from that, you can then identify what requirements do you have. How are you going to decide whether you meet those requirements? What are the acceptability criteria and metrics? And what information are you going to need to develop those metrics? So it all flows down from this intended use statement. And the reason for that is people waste a lot of money on V&B. They sort of start by saying, well, I guess we're going to have to walk through the code and do detailed code analysis, and we're going to have to do this and that, without really stopping to think about, well, how does that tie with how I'm really using it? So what you need to do is start by asking yourself, what questions am I trying to answer using model and simulation outputs? And what what outputs am I going to have to use? And once I can answer those two questions, then what characteristics does the model have to give me those outputs? What information do I need to show that it has those characteristics? Once I can look at what I have available, what's missing and how can we develop it, and what are the risks of not getting that information? So this all kind of flows from that first intended use statement. Now, the thing is, very, very seldom is this done already by the time a VV&A team gets involved. So you have to kind of help them develop this intended use statement and go through this whole process. So, and that's what we've done for a number of programs. So here's an example of a general intended use statement. This was come up with by the VV&A branch there at NAVAIR. This is an example. Suppose improve the traffic flow in and out of the base at Pax River. And so I want to develop a model of traffic flow to do things like figure out how well the current traffic control system works. How does it vary depending on how the traffic flow varies? And if I change it, how does that change things? So that's what we'd call a general intended use statement. It's an explicit statement of how you're going to try and use this tool, but it's not detailed enough really to develop requirements. So what you do is come up with a matrix like this and say, for each of those things that I just said, simulate traffic flow, support improvement of the traffic flow, and future modeling. What questions am I trying to answer in order to do that using the model outputs? How does that really apply to my problem? And what model outputs am I using in order to answer that question? So you go through this for each intended use, and this is what we'd call a specific intended use statement for this particular problem. And from that, then you can start to develop requirements and acceptability criteria and metrics for evaluating whether you're able to do that. So from that, then you develop and ask yourself, does the model do what I need it to do to answer those questions? How accurate do they need to be? And what's in place to ensure that it's used properly. So you start to see here, now we're talking about credibility, accuracy, and usability in relation to that matrix that identified the specific intended uses for the tool. So we fill out this form. We take each of those questions and how it came up and what are the requirements for each of those intended uses in terms of capability, software accuracy, data accuracy, output accuracy, and usability. What are our criteria for those, and how are we going to measure it? So this is just kind of a general overview of what that sort of table might look like. This is an actual example from one we did for a 6 degree of freedom aircraft flight simulation. And this is just one teeny tiny slice out of that table for that program, a piece of the atmospherics part of it, and just one element out of the air vehicle part. We also looked at propulsion and flight controls and a bunch of other general areas. But you can see that there were specific requirements identified in order to really do the atmospherics or the air vehicle simulation. For air vehicle, simulate mass properties. The first acceptability criterion is, well, does it accept the mass properties database in the first place? And then the second is, do they agree with what would have expected from the database itself? And then the metrics are verifying both of those things. So what we'll see later is a continuation of the example that shows how we did that. But this is just a small piece of that specific intended use and requirements, acceptability criteria, and metrics table. Now, you'd think requirements wouldn't be a hard thing to do, but like I said at the beginning, people tend to pick up existing models and use them that were developed by somebody else. Now, this is an example of what happened when they did that. One program wanted to look at effective time on station. That's a parameter or metric that's used by reconnaissance and surveillance vehicles. You've got an area of the ocean or wherever you want to cover continuously with sensors, and you've only got a certain number of aircraft to do that. So ETOS is really the total time the mission area is covered by an actual aircraft on station divided by the total coverage time required. So it's sort of a percentage of the time you're actually out there compared to where you thought you needed to be. So they picked up this ETOS model that came from another program, and they had an intended use statement, but no requirements. They figured, well, this is the same kind of problem, kind of system. It ought to be usable for us. But when it came time to actually try to verify or validate that simulation for this program, it turned out the program office was changing requirements during the development of these enhancements. They couldn't agree between the developer and the program office on what the requirements were. And so that meant there weren't any software design requirements. So we worked with the developer to come up with some software design requirements and used them as testable parameters and went from there. And I'll have another slide later that kind of shows how we ended up with that. But the problem was they didn't have any real detailed requirements to start with. So that made it hard for them to figure out where are we in terms of that simulation. So once you've kind of gone through this whole process, now you've identified your requirements for capability, accuracy, and usability. Now you can do an initial risk assessment. You've got some information, it's available already. You haven't done any V&V yourself yet, but you should have information provided by the model developer to tell you where you stand in terms of your requirements. If you do an initial risk assessment, then that guides what you put in the V&V plan, because you don't want to do any V&V unless it specifically helps you reduce the risk for your use of the tool. Now, NAVAIR uses a risk process that's derived really from the system safety process. So we come up with a risk cube based on consequence of error and likelihood of error. And the likelihood of error is a couple of different steps. I'll show you what one of them is. And the consequence depends on how reliant are you on model and simulation results, and how important is your ultimate decision. So in terms of likelihood, we look at 10 characteristics of the model and simulation and evaluate, is it a high risk area, a moderate risk area, low risk area, and what's missing? So as we go through each of these steps and look at software design validation, for example, have they done that at all? Is there documentation of it? Was it complete? Did it cover all the parts of the code design that I'm interested in? And in doing that, you can identify, well, what's missing? What pieces would I like to see, and compile a list of things that should have been done for your problem that weren't. And then you could use that list as a starting point for coming up with a V&V plan. In terms of error consequence, like I said, it's how much are you relying on the tool to make a decision? Is it the only source of information? You have other data, but it's the primary source. Is it just kind of a secondary method to supplement everything else? Or is it just so you'd like to be able to kind of verify everything else at the end? So how much are you relying on outputs from this tool to make your decision? And the other part is, how important is your decision? Are you looking at ORD thresholds? Are you evaluating the key KPPs? Does it involve system safety? If somebody's going to be killed if the model is wrong, then that's a pretty important application of the tool. So we combine all those into this risk cube, and we have error consequence on the bottom, where 5 is the highest consequence, and error likelihood, where 5 is the highest likelihood that there's an error. And you can look and see where you are in that cube and decide, well, what am I going to do about it? If you conduct V&V, you're driving yourself down lower in the error likelihood, so you're improving the credibility of the tool. But for instance, you might look at that and say, well, I'm in the consequence 5 category. I'm in the red right now, but even if I do a lot of work to improve the credibility of the tool, I'm never going to get to low risk, because that 5 bottom box is yellow. So you may say to yourself, well, in addition to doing some V&V, I'm also going to look for other sources of data that I can use in addition to or in lieu of the model results, and reduce my reliance on the model in addition to making it better. So you can make some decisions based on where you are in this risk cube. So based on where you are in that risk cube, then you can identify what sort of V&V tasking do I need to do. Now you compile that list from before, so that's a starting point for things you need to do. But we also have what we call the Accreditation Information Requirements Guide that we've developed over the last, more like 40 years, really. I was a joint project manager for a OSD-funded program back in the 90s, and we did a survey as part of that on what information did acquisition programs and organizations like OPTEV4 and AFOTEC and Air Force Studies Analysis, what did they want to see about a model and simulation's credibility to make a decision that they could use it? So we interviewed a bunch of people and a bunch of organizations, and came up with what we call an error guide, which kind of helps identify what sort of level of activity you need to do depending on the risk involved. So here's an example of the software verification part of that. And we identified also some typical sources if you're picking up somebody else's model, where to go look for that kind of information. But then it also identified, based on those interviews, what people said about how much detail they needed in that verification result to support a accreditation decision, depending on whether it was low, moderate, or high risk. So we have that tool that we use just kind of as a guide. And as an example, if you have a moderate risk application of the tool, these are the things that Air Guide says you ought to consider looking for, and that those program managers and organizations said they'd like to see to help support making an accreditation decision. So you can see it's a list. We just, like I say, we use it as a guide. We actually use the results of our risk assessment and that list of things that needed to be done as more specific indicators. But we also look at this and say, well, what else might we be missing if we need to do some more work? So going back to that effective time on station model example, just to show you sort of how it all came out. We started with their version 1, and once we developed some requirements, then we could do some verification testing. Found a bunch of errors. We did a software quality assessment just to see, is it because of the way it's coded or is there something else going on? It turned out relatively small code and it just wasn't separated into objects very well. We did a subject matter expert review based on some sensitivity analysis and their review of what verification testing were done. And they identified some more errors and also said, well, if you can fix the ones we know about, it's probably going to be usable. So the developer addressed a bunch of those bugs, developed version 2. We did some more verification testing, found new errors, corrected that in version 3. And actually, it went to 4 versions before it was actually usable. But you probably could have avoided a lot of that if you had some detailed requirements and verification test requirements up front. Another point to make is it's always a team effort. A lot of people like to say independent verification and validation is the way to go because they want to keep the developer out of the V&V loop. But the trouble with that is that the developer is the one that really knows the model the best and can help answer questions that come up and can also show and suggest ways to fix any problems you identify. One of the guys on our project team back in the 90s said he always thought of IV&V as ignorant V&V, but he was biased. But the point is really that you need to involve the developer because he knows the specific model. The V&V team knows how to do this, and subject matter experts know the technical area, but they've always got their own biases and grudges. When we first started doing V&V on our radar model, the developer kind of reared up on his hind legs and said, who are you to tell me whether my model's any good? Well, once we showed him that there was a bug in his program that had been there for 20 years, he became more of a team player and actually was very helpful on some other programs as well. So if you kind of get everybody working together, the other thing about subject matter experts is they tend to want to focus on it. Well, that's not how I'd have done it. But that's not the point of their review. The point of their review is, well, this is how we did it. Tell us what you think about it. So it is a team effort, but you kind of have to work at it. So once you get to this point, then somebody, the program manager or the operational test director or DOT&E, is going to have to make a decision that, yeah, okay, I understand what the risks are. I understand whether I need workarounds and limitations, and I'm going to agree to either accredit it or not. So what we do is add a column to the requirements, acceptability, criteria, and metrics table for an assessment. So we did a lot of work and we came up with a lot of new information. And we did another risk assessment to identify, well, what's the residual risk of using this? But I did that by going through every step of this requirements, acceptability criteria, and metrics table and adding an assessment to it. And this kind of shows you how we did this for this particular 6-DOF flight simulation. So, for example, on the last one, the mass property parameters agree with the output. The V&V report that the contractor, in this case, developed showed how they matched. The subject matter experts reviewed that. They were comfortable with it. But they also said, well, there's one additional document that needs to be added to the references, and they were going to provide that. So this was a detailed process that we went through for this model, which is only one of a number of models that this program is using. So, but this kind of gives you an idea how we did that. We came up with an assessment for all of those, and then it goes into an overall assessment. It also identified some limitations to the code. So the accreditation really was, we accredit this, but with these known limitations, you can't use it here, but you can use it in these areas. Another word on subject matter expert reviews, what you need to do, if you're going to have a subject matter expert review the tool, what you need to do is show them how it behaves. And the best way to do that is in using sensitivity analysis. And here's an example for the effective time on station model. We did some sensitivity analyses, and this was one of them. It's a time on station as a function of unrefueled endurance in the platform. So you would expect that the longer the aircraft can be out there flying around, the better the effective time on station should be. But that's not what the model said. It looked like this. It went up until you got to 12 hours and it flattened out, which is reasonable. But then it went down. So why would toes go down with more endurance? Well, it turned out that this tool was developed for an aircraft carrier launched platform. And the tool also has in it when scheduled maintenance occurs. And the tool actually called back the aircraft from the sortie when it was time for its scheduled maintenance, instead of waiting until the sortie was over and doing the scheduled maintenance when it came back. But even worse than that, because it was a flight deck, the deck was closed at night. So it couldn't relaunch, and so it was just a bug that hadn't been found. But the subject matter experts looking at this said, well, this is really screwy, and then they went and looked at why that happened, and so that was a result of an analysis of the sensitivity analysis. So this is actually a condensation of a much longer briefing, so it's a little disjointed in spots, but the point really is that VV&A is risk reduction and mitigation, and you're comparing your requirements with what information you have and assessing the residual risk using capability, accuracy, and usability as acceptability criteria and metrics. And we call this a cost-effective way because you're focusing V&V on only those things that are important to you. And you're making, I didn't talk about this really, but you're making maximum use of existing information documentation and subject matter expert reviews. So this is a process we've had in place now. We started using it back in the late 90s, and we've used it for a whole bunch of acquisition programs, not only within the Navy, but in other services as well. So I think it's time for the question and answer session. I'm done. So Taylor.
Yes, great. Thank you so much, Dave. I really appreciate it. Let's see. I'm going to pull up. Now's the time if anybody has any questions, if you want to go ahead and type them into our audience question bubble. We can go ahead and go through them. As of right now, I don't see any questions for you, Dave.
Okay.
So I'll give about a minute, 30 seconds if anybody wants to type anything in. And also, if you don't have questions now, if something comes to mind later on today, next week, you can also contact Dave directly. I don't know if you want to type in your POC information in the chat, or I can have Sharon do that. We can share that with everybody, Dave, so that somebody can, if you're okay with that, they can contact you directly.
Sure.
Great. So we'll put that in the attendee chat. And I do have a question. So during the SW verification step, do you implement or execute any automated test cases or steps?
Yeah. If you have the ability to do automated test cases, that certainly helps. Especially if you have an extensive code, you can do a lot of testing. If you can automate it, it's much easier than trying to do it by hand. So yes, we do use that.
Okay, great. And then our next question is, how do you handle the increase in complexity of M&S tools and models?
Well, if you think about, like, for instance, if you look at federation of models and simulation, that's certainly an increase in complexity. The way we tend to look at any tool is in terms of a functional area breakdown. That if you can, for instance, if you have a radar simulation, you're looking at the antenna, you're looking at the environment, you're looking at propagation, the receive antennas, the signal processor. So they're all pieces, and you have to do V&V on all the pieces, but also how those all fit together. So it's kind of a bottom-up approach to verify and validate the elements of that, and then put those all together, but look at how the performance of the integrated model works. And it's really the same thing with federation of tools, is you have to do this process for each of the federates with your intended use in mind for the outputs from that federate, but then also look at how do they operate as a federation, and what are the overall outputs of that federation, and how do those support answering your questions. So it's, the more complex the tool, the longer it takes and the more expensive it gets, but it's really the same process. You kind of break it down into pieces that you can evaluate and then show how they fit together. I don't know if that answers the question or not.
Great. So our next question, does this relate to MIL Standard 3022 standard practice for documentation of VV&A and the DoD Modeling and Simulation Enterprise Recommended Practice Guide?
It does. The MIL Standard 3022 is really the documentation standard. So we've tailored, when we do verification and validation plans and reports and accreditation plans and reports, we started from the MIL Standard 3022 format, but we've tailored it somewhat. We don't use all of the appendices, and we actually have inserted a risk assessment appendix in the ones that we do to supplement that standard. As far as the RPG goes, actually, we wrote some of that years ago when we started. The RPG was started to be put together. I came from China Lake. I was a civil service for the Navy there, and as a result of that program I mentioned back in the 90s, we actually developed some of the language that's in the RPG. So the RPG talks about a lot of stuff, but part of it, unless they've changed it, describes some of this same kind of process.
How early in the start of a new development program should planning for VV&A begin?
Right away. Part of the problem with the way do V&V and accreditation is they kind of start too late. And what you really ought to do is start planning for that at the very beginning. For instance, if you want to do validation testing, That is, if you want to, once your system gets to the point where you can actually test it, you have to, when people do testing to demonstrate whether their system meets the requirements, they only collect the information out of that test that really supports their ability to show whether it meets the requirements. They don't typically collect the kind of data and the fidelity you need to do validation of the model of the system. So if you get involved early enough, at least in the testing process, you can influence the data collection so that you can actually do model validation as well as system compliance, evaluating system performance. And that also goes early in the program if you're trying to use tools to develop requirements or to validate requirements, then you really need to start thinking about VV&A at the very beginning if you're going to use them to support doing that as well. So, oftentimes it's really late in the program when people start thinking about it, and it's almost too late to really influence much of anything.
Okay, so this one is talking about something you mentioned earlier about developers changing requirements, that it was frowned upon. How should developers handle requirements that need changing based on new information gathered during development?
Well, the biggest problem with the program I talked about was that they didn't have any requirements to start with. And that when they were in the process of then trying to develop some, there was no coordination between the software developer and the people in the government that wanted the software developed. Obviously, requirements are going to change as you progress through the program, and the real issue is that it needs to be coordinated with the people that are actually doing the work. So you have to make sure that the model developer, the software developer, understands what these changes are, and that the program that's making the changes understands what the implications are going to be on the schedule and the cost of developing the software. So it's really more a communication problem than it is a requirements changing problem, because requirements are going to change. It's just the way things tend to work.
Instead of strict M&S, can this process be used on a test environment in a lab versus installed on the intended tactical platform?
Yeah, that's a good question. Actually, we've done that. We've applied this process to several different lab environments. One out at I've forgotten where it is exactly. It's over by Pax River. Was looking at testing, lab testing IFF systems, and so we applied this process to that test environment, and we've done it for several others as well. So yeah, it works just as well. You have to kind of modify some of the things you look for, but yeah, the process is still the same. You're looking at what's the ultimate goal of the lab and how it's doing testing, and how well does it do that job. And you can break it down into similar kinds of sub-elements and evaluate those.
New programs are using digital twins. How does this interrelate with VV&A?
Well, yeah, you probably have VV&A, but digital twin, it seems to me, indicates a really much more detailed level of verification and validation to ensure that that digital twin, in fact, is a mirror of the system it's modeling. And the same basic principles, it seemed to me, would apply, that you're developing requirements for that digital twin that are derived from how you're going to use it. So you have to identify, well, what parts of this system am I really trying to mimic? And, how am I using it? Am I using it to model all of the system? But what does that mean? I mean, is it you're modeling the flight, or you're modeling the structure, or you're modeling the electromagnetic characteristics? So your intended use drives the requirements for the digital twin, and then from that, then you can derive the requirements and the acceptability criteria and metrics and how much information you need to support evaluating the credibility of the tool. So it seems to me it's the same kind of idea. It's just maybe a whole lot more detail.
All right, next up. Can VV&A be conducted internal to an organization?
Yeah, it depends on what you're doing and who are you doing it for, and how big an organization you're talking about. If you mean within, say, well, I'm trying to think of an example. If you got a small program, well, for example, we had a program where one guy developed a tool and he was the only user and he was using it for one program. So he did the V&V, he just didn't document it very well. And we went through his files and ferreted out a bunch of testing that he'd done that he didn't write down. And he had come up with a lot of information that supported the use of the tool, and basically by interviewing him and come up with some documentation that was informal, it was stuck in his safe, we were able to make an accreditation case that the program then accepted. So yeah, it depends on the size of the problem, the size of the tool, and the size of the organization. But yeah, I don't see any reason why they can't be done. For example, the OT organizations, well, they don't typically do their own V&V, but they do their own accreditation for tools that they use in support of operational tests.
Okay, the lab would be part STEM, SIM, and part tactical equipment. If yes, would there be any tips or areas to watch out for to modify process?
That's a good question. It's been a couple of years since I did any of that. I think the thing to be looking for is just keeping your eye on how am I using the modeling and simulation parts of this lab, and what are the requirements for those, and there's some hardware involved, and how does the software either drive the hardware or vice versa, and are those links properly established. For example, we did one of it was an IR missile simulation that had actual signal processing hardware involved, and they were modeling the environment and the seeker and the propulsion and the controls and all of that, but the signal processor was the real thing. So the question really was, does the environment that they're modeling and the seeker and all of that provide the signal that the signal processor really needed? So it really was, what's your intended use for the software, and how does that interact with the hardware pieces of it, and are those doing it properly, and how credible is your representation of the environment and the dome on the seeker and that sort of thing. I don't know if that answers the question, but yeah, it is a complication that you have to look at.
Great. And then we have our final question. Should be popping up. It's not popping up. Let me double check. There we go. During the SW verification step, do you implement or execute any automated test cases and or steps?
Yeah, we do that where it's possible, because you can essentially do complete testing if you do automated test cases in the right way, and you can set those up. It allows you to look at all the possible combinations of things where you really couldn't do that manually. or if you did, it'd take you a long time. So yeah, we definitely do use automated test cases.
Okay, great. Well, that wraps up our Q&A portion. I really appreciate everyone for joining in and listening, taking the time out of your day to join our webinar. And thank you so much to Dave for presenting and sharing his expertise with us. Again, if you have further questions, you can reach out to him directly. And also, if you have any follow-up questions about this topic, you can also submit a TI through DSIAC's website, and our analysts are happy to help you out. Thanks, everyone.
Thanks.
All right. Have a great day. Bye.